Consider this situation. Assume there is a conveyor belt, as you can see. Let's say it is moving with a constant speed v. Okay, I don't mean the system is going away. The belt is rotating with a speed v. And assume there is a box. You can assume the mass of the box is m. And let us consider the belt to be a rough surface. Or, okay, let's take smooth first. You all tell me, if we gently place this box on the conveyor belt is already moving, okay? Belt always moves with the same speed v, okay? It has its own mechanism. If you gently place the box on the belt here and the belt is perfectly smooth, what will happen?
Sir, it'll start moving at the speed of v.
Why will it start moving?
Sir, because the conveyor belt is already moving, right? And when you're placing,
Think careful. Don't be in a hurry to answer, okay? Make sure your answer is correct. Pawan, what do you think will happen if we gently place the box on the conveyor belt, which is smooth? What will happen?
It will stay at rest.
The box will stay there itself. Okay. There will be two forces acting on the box. One is its weight. The other is normal force from the belt. These two will balance. Horizontally, there is nothing to make the block move at all because the belt is smooth. Okay. So if it's a smooth belt, nothing is going to happen. The block will stay where you put it. Suppose it's a rough belt. And let's say coefficient of friction between the box and belt is given to you. Both for coefficient of static friction and kinetic friction, you use the same mu value. Now think carefully and answer. If the box is gently means with almost zero speed, okay, placed on the belt, first tell me what exactly happens. Think carefully and answer, any one of you. If the box is gently lowered onto the conveyor belt, which is already moving with a speed v, what exactly will happen? The belt is rough.
So the
Okay.
box might move because of the friction between.
Okay. Okay. It may move because of friction. So you can't tell for sure. And Pawan is saying initially it stays at rest for some time, then it starts moving. Pawan, why should it stay at rest for some time and then why should it start moving?
సార్ సమ్ టైమ్ అంటే మరినంత కదా సార్, అంటే డిటి అంత చాలా.
Okay, for one instant you are saying. For one instant it will stay at rest, then it will start moving. Is that what you are saying? Okay. And when it starts moving, will it move with the speed v immediately? And Vanilla, you also, you said because the belt is rough, it will move along with the belt. So are you saying it will move with the same speed v?
Sir, if enough friction is there, I think it will move with the same speed.
Okay, we'll see. Aishwarya, what are your thoughts on this? What will happen when the box is gently lowered onto the belt?
Sir, I assume it will move.
Will it move along with the belt, like with the same speed v, or in any different way?
So not with the same speed till it overcomes the static friction, but then later it will start moving.
Okay, you said it has to overcome static friction. Fine, fine. Rishi, what is your opinion?
Sir, once you lower it down at one small instant, it won't move and then it'll start moving.
And when it starts moving, it'll move along with the belt with a speed v or some other speed.
It should move at the speed of v only.
Okay, let's see. Listen, all of you. None of your answers are totally correct. Visualize what is happening here properly. The belt, every part of the belt is moving with a speed v like this. Okay, that is how a conveyor belt moves. Right. Now, the box is gently being lowered onto it, means it is initially at rest. Now, you all tell me, almost all of you were of the opinion that it will move with the belt. Which force makes the box start moving horizontally? Which force makes the box move horizontally once it is placed on the belt?
Friction, sir.
Friction, obviously. Okay, because you told in the previous case, when it is smooth, the box is not going to move. Correct. When it is smooth, the belt will keep rotating, but the box won't move. But now, the point of the belt with which the box is in contact. Okay, let me mark it in green. The point of the belt or the region of the belt with which the box is in contact, that region is moving forward. The box is at rest. Okay, so relative to the belt, the box is sliding on it, and relative to the box, the belt is sliding below it. Okay, belt is sliding forward. Relatively, the box is sliding backward. Actually, box is not moving, but with respect to belt, box will appear to go back initially. Okay, so belt is sliding forward below the box. As a result, what will happen? Friction on the belt will act in the backward direction. But see, the belt is connected to a motor. The motor will ensure that the belt runs at the same speed. Okay, so if friction is acting, the motor will put extra effort and it will make the belt continue moving at the same speed. So you don't have to bother about the change in velocity of the belt. Belt will keep moving with the same speed v. Okay, now relatively, the belt was sliding forward, so friction on the belt is backward. On the box, if you see, the friction will act in the forward direction. Friction on the box will be in the forward direction. Do you all agree with this or not? Any doubt in this? On belt, the friction is backward. On the box, the friction is forward. That is why it moves forward. Okay. Hope this is clear. Now tell me, what kind of friction acts between the box and the belt the moment you place the box on the belt? What kind of friction acts between the box and the belt when it is just placed on the belt?
Kinetic friction, sir.
Okay. Why? Answer is correct. Why is it kinetic friction?
Sir, because the block slides with respect to the conveyor belt.
Correct. See, these two objects, the block and the part of the belt below the block, they don't have the same speed. They are block is at rest, the belt is moving. So relatively, they are not at rest. There is relative sliding between them the moment you put the box on it. Okay. So the friction acting will be kinetic in nature. Fine. And you know the formula for kinetic friction. So you can tell how much friction acts on the box after it is placed on the belt and released. And friction, since it is acting in the forward direction, it accelerates the box. As a result, what will happen? After some time or after sliding for some distance, okay, throughout that path or throughout that distance, friction would have acted on it. Kinetic friction itself would have acted on it. But after sliding some distance, the box will gain a speed equal to that of the belt. Because friction will keep on acting as long as there is relative sliding between them. Okay. So at some instant, the speed of the box becomes equal to the speed of the belt. Okay. We'll assume the belt is long enough for that to happen. The box does not fall off from the belt before reaching its speed. Okay. Before gaining the speed. So when it after it covers some distance, like throughout that distance, it is accelerating under the influence of friction. And because acceleration is there at some instant, its velocity will match that of the belt. Once their velocities become equal, what will happen? After the velocities become equal, what will happen? Vanilla, don't answer. Anyone else?
Sir, with respect to belt, block rest lo ఉంటుంది.
Once the velocities become equal, relatively they are at rest. Okay. So will friction continue to act on the box or not? Will friction continue to act on the box or not?
Sir, there should be no friction acting, like, because both of the speeds are matching, right? Then what is it supposed to like
Achieve.
reduce?
Yeah, friction has nothing else to do after that. See, till that instant, till the moment the box's speed becomes equal to the belt's speed, friction will act because there is relative sliding between them. Once their speeds become equal, relatively they are at rest. The box is simply moving along with the belt. It's not sliding on the belt anymore. And it doesn't have a tendency to slide also. Because once it gains that velocity, friction's job is done. It has prevented sliding. After that, there is nothing to change the velocity of the box. We are not pulling it back or pulling it forward with any other force. So it will continue with that velocity. And the belt anyway moves with that velocity itself. So both will have a tendency to automatically move with the same velocity. Then there is no need for friction to act. Friction will stop acting. Okay, so this is what is going to happen. And some of you said it will immediately get the speed of the belt. See, in a real life situation, it may look like immediately getting the speed. Like some of you may have the experience of putting bags on an airport conveyor belt or picking up bags from an airport conveyor belt. The moment you put the bag on it, it tends to move along with the belt, but it takes a little bit of time. There will be a little bit of sliding happening. Okay. And someone said, if there is sufficient friction, it will immediately start moving. That is correct. Immediate word should not be used, but if friction is very high, in a very short time, it will start moving along with the belt. If friction is not that high, friction is there, but not that high, then it will slide for a significant amount of time and then only start moving with the belt. Okay. So assume friction is moderate in this case. So the box slides for some distance for some time before it gains the same speed as the belt. So see, in exam questions, they won't tell you all this. They'll just say a box is gently placed on a moving conveyor belt. and they'll start asking you questions. So you have to visualize all this. Anyway, so we imagined what is going to happen. Now the first question, or the second part of the question, you can say. Distance moved by the box before it starts moving along with the belt. Try this, all of you. We are making the assumption that the box does not fall off from the belt. Okay. You know what force makes the box accelerate? From force, you can find out acceleration, and you know what velocity the block is supposed to attain. Okay. So in the question, V is given to you, friction coefficient is given to you. Mass of the block is also given to you, but I think mass will get cancelled. And you know its initial speed is 0. Use all these values and find out how much distance it slides before its speed matches that of the belt. Okay. What happened? Any answer? Okay, try. I'll give you 1 more minute. Okay. I shouldn't be taking this long. Pawan, tell me, what are you trying to do?
సార్ 2 ఈక్వేషన్ ఇక్కడ రాసుకున్నాను సార్. అంటే f ఈజ్ ఈక్వల్స్ టు ma ఇంకా f ఈజ్
Ah.
ఈక్వల్స్ టు µs ఇంటూ n.
Okay. After that, you didn't get A.
వచ్చింది సార్, ఏ వచ్చింది.
With acceleration, you didn't find the distance.
సార్ ఒకటి వచ్చింది కానీ అది కరెక్ట్గా తెలుసు సార్. v² µs g.
V square by
µs g.
mu g. Okay, we'll see. We'll see. So listen, we know the box accelerates because of friction. Fine. And what kind of friction? We know it is kinetic friction. Once the box is placed on the conveyor belt, the forces acting on it are its weight mg downwards, normal force upward, and friction to the right. Normal force should be balancing mg. Okay. And since the friction is kinetic friction, you can say that friction is mu n, which is mu mg, because normal force is mg in this case. And this force is the net force acting on the box. So you can equate it to mass into acceleration. That's all. That means the acceleration of the box is mu g as long as it is sliding on the belt. As long as kinetic friction acts on it, the acceleration is mu g, and this will be constant. So you can apply equations of kinematics. Initial speed of the box is 0. Final speed is v. And you need to find out the distance traveled to gain that velocity. Which equation of kinematics can be used?
v² - u² equal to s.
V square minus u square is 2as. That's all. So v square minus u square is 2. Acceleration is mu g into s. The distance the box moves before its speed matches with that of the belt is v square by 2 mu g. And this is the distance moved with respect to ground. Okay, what was so difficult in this? Others, like, where did you get stuck? If any of you have any doubts, you can ask. Okay. Now we observed everything from the ground, so the equation was also written from with respect to ground. The answer you get is also with respect to ground only. Okay. You can solve the question with respect to belt also. With respect to belt, the situation actually is reverse. Initially, the block is sliding on the belt. Finally, it is not sliding. So initially, the box has a speed v relative to belt. Final speed of the box will become 0. Now you will tell me one thing. If we make the belt the reference, okay, any point on the belt we take as the reference, will it be an inertial frame or a non-inertial frame? If we make a point on the belt as the reference, will that point be an inertial frame of reference or non-inertial?
Inertial, so
Inertial frame.
Correct. Okay. Points of the belt are not accelerating. They are moving with a constant velocity. So it will be an inertial frame. Good. Okay. So that's the distance the box will have to slide before it starts moving along with the belt. Okay, fine. Same situation. Calculate time taken for this to happen. Time taken for the speed of the box to match that of the belt.
v by mu g, so
Okay, which equation of kinematics will you use for that?
v equal to u plus 80.
V is equal to u plus 80. That's all. Correct. Initial velocity is known. Acceleration is mu g. Final velocity is v. From that you will get. Hope this is clear to all of you. Yes.
సార్ s equal ut plus half at square కూడా బెటర్.
You can use. You can. Since we calculated the distance that it is going to slide, you can use s is equal to ut plus half at square. Okay. Just a moment. I'll give you another question. slight variation in the system. Suppose the situation is now like this. Okay. Same rough conveyor belt. Coefficient of friction is mu, box mass is m, belt moves with a speed v. This time the belt is inclined, let's say at an angle 37 degrees with the horizontal. Okay. First you all tell me what will happen if the box is, okay, yeah, we are going to keep the box on the belt and leave it. What will happen if the belt is smooth? Put the box on the belt and release it. What will happen?
Will go down, like it'll slide down.
Under the influence of which force will it slide?
Gravitational force.
Okay, properly speaking, it is mg sine theta. Okay, the force along the incline pulls it down the incline. Okay, there's no friction, so it will simply slide irrespective of how the belt is moving. The angle is theta, 37 degrees or theta, whatever. So mg sine theta will pull it down the incline, down the what do you call belt. Okay, so you know that points of the belt are moving up. Fine. And the box has a tendency to move down. So I told you, any question involving friction, you first have to imagine the situation without friction. So without friction, this is what is going to happen. So there will be sliding between them. Okay. Same question again. Coefficient of friction is given to you. Take the angle as theta, not even 30 degrees. Take it as theta. Calculate distance moved by the block before it stops sliding on the belt. And it is given to you that mu is greater than tan theta. Right. The box is gently placed on the belt, means when it is placed on the belt and released, it's at rest. It has to gain velocity after that. Okay, calculate distance moved before it stops sliding on the belt. Stop sliding on the belt means it gains the same velocity as the belt. Any answer, anyone?
V square by 2g into mu cos theta minus sin theta, sir.
V square by 2g, and that into part is in the denominator or numerator?
Denominator, sir.
So 2g into mu cos theta minus sin theta.
Yes, sir.
Okay, we'll see. Any other answers? Fine. Listen, all of you. Situation is like this. The box is just placed on the belt and it is released. Belt is moving with a velocity v. We need to find out the distance moved by the box before it gains that velocity v. So we know the initial velocity of the box, 0, and we know final velocity also v. Okay. All you need to know is acceleration then. With that you can tell what distance it is going to move before gaining that speed. And where will you get acceleration from? Rishi, tell me, how will we get acceleration of an object generally? Aishwarya, how to get acceleration generally? Okay, your voice is breaking, but I understood. Using F net equal to ma, correct? You have to visualize the forces acting on the box. Now we have already visualized what is going to happen had the belt been smooth. Had the belt been smooth, it will slide like this. Box will slide down. Okay. So friction will act on the box and it will act up the incline like this. Along with friction, the other forces will be there, the usual forces. So mg cos theta this way. So you all need to practice some more problems. You have to confidently visualize the forces and start writing equations. Okay, mg cos theta will be there, mg sin theta will be there. And because there is relative sliding, friction will be there. And of course, normal force from the belt. Okay. Motion of the box is only along the belt. There's no motion perpendicular to the belt. Therefore, we can say n is equal to mg cos theta this time. And the box is gently placed, means box was not moving, but the belt was moving. So relative sliding is there between them initially. So the friction acting will be kinetic in nature. Till the box gains the velocity of the belt, relative sliding will be there between them. Kinetic friction will act. Therefore, we can say friction is equal to mu into normal force. That is mu mg cos theta is the friction this time. Okay. Now, initially the box is at rest. Finally, it has to gain a velocity v. In which direction? In this direction, it has to gain the velocity v. So we'll have to take acceleration also in this direction. For acceleration in this direction, up the belt, you should write net force as friction minus mg sin theta and equate it to mass into acceleration. And friction, you know, is mu mg cos theta. M gets cancelled. You will get acceleration as mu g cos theta. Friction was mu mg cos theta. M gets cancelled. So acceleration is mu g cos theta minus that m also gets cancelled, g sin theta. And this will be constant because the inclination is constant. That's all. Then you apply equations of kinematics. V square minus u square is 2as. U is 0 anyway. So you can write v square is equal to 2as, or s is equal to v square by 2a. So the distance slid before it attains the same velocity as the belt is v square by 2 into all this. You can take g common, mu cos theta minus sin theta. Good. Any doubt in this? If any of you are confused, you can ask. Okay. Assume the belt is long enough and the box covers this much distance and gains the velocity equal to that of the belt. Now think and answer. Okay, if you have an answer, directly tell. What happens after the speed of the block becomes equal to speed of the belt. Like what happens after the box covers this distance and matches the speed with the belt?
Sir, is it like the situation where it just slides off due to mg sin theta acting on it?
Will friction
there-
disappear?
But in the last case, it matched the velocity of, and then there was no friction acting on it, right?
In the last case, see, because there was no friction in the last case, doesn't mean there won't be friction acting in this case, no? How do you decide whether friction acts or not? Or in the last case, how did we confirm that there won't be friction acting once the velocities match? Anyone? In the last case, how did we tell that friction will stop acting once the velocity of the box becomes equal to that of the belt?
So because there won't be any slipping between them.
First, when the velocities match, slipping will be gone. And after that, there is no tendency to slip also. See, velocity of the box becomes equal to that of the belt. I'm talking about this case that you see on the screen. Velocity of the box becomes equal to that of the belt. After that, there is no other agent trying to speed up the box or slow down the box. So there's no reason why they will start sliding afterwards once their speeds become equal. Okay, so there's no need for friction to act in that case. That is how we confirm that friction will stop acting. Now you consider this situation and tell me what will happen after their speeds become equal. Pawan, what do you think?
Sir, with respect to belt, rest like that.
Yes. The moment the box speed becomes equal to belt, with respect to belt, it comes to rest. I'm asking whether friction acts after that or not.
No, sir.
Why? How did you confirm that there's no need for friction to act after that?
Sir, sliding aim there, sir. Sir.
So he's saying the box is not going to slide afterwards. We'll see. Aishwarya, what do you think? Okay. Vanilla, what do you say?
Sir, I think static friction will act because of mg sin theta.
That is correct. See, once the box gains the velocity of the belt, sliding will stop. Okay, so kinetic friction need not act after that. But mg sin theta will tend to slow down the block. Okay, even after getting the velocity v, mg sin theta will continue acting on it. If friction disappears due to mg sin theta, the speed of the box will have a tendency to decrease. It won't keep up with the belt. Okay, so what happens once their speeds become equal, the friction converts to static friction. Why? Because sliding has stopped, but there is a tendency to slide because of mg sin theta. In the previous case, the belt was horizontal. There was no force acting this way or this way on the box. So once the speed becomes v, there is nothing to slow down the box or speed up the box. But in this situation, even after the speed of the box becomes v, there is mg sin theta trying to bring it down. Okay, so if friction disappears, the box will slide down the belt. Fine, or you can say belt will move faster than the box. So friction needs to act and static friction will act. And that is why you were given mu is greater than tan theta. Mu is greater than tan theta means what? Friction is sufficient to support it on that incline. Okay, if this was not there, okay, suppose mu is less than tan theta, then the box will slide down. It can't match up with the belt at all. Okay, why? If mu is less than tan theta, you observe this acceleration equation. In place of mu, if you take exactly tan theta, tan into cos becomes sine, and the acceleration becomes 0. If mu is equal to tan theta itself, the acceleration of the box becomes 0. It can't keep up with the belt. The box needs to have positive acceleration upward to match its speed with the belt. Okay, so if mu is tan theta also, the box cannot go up along with the belt. And if mu is less than tan theta, then this acceleration becomes negative, means the block will slide down. Mg sin theta will dominate, friction cannot dominate, and the box won't go up at all. The moment you release it, the box will go down. Okay, that is why this was given to you. Okay, did you all understand? Any doubt in this? After the box comes to rest also, there will be friction acting on it, and it will be static friction. Okay. Next, see, these are slightly high level questions, but you should understand the importance of visualization in while solving a physics problem. Okay, and all conditions matter. That mu greater than tan theta, why it was given. Okay, that also you should understand. If mu is greater than tan theta only, this acceleration will be positive, and the box speed will increase in the upward direction. Otherwise, box speed won't increase in the upward direction; it will go down. Okay. Next, just a moment. Okay, assume this is a table surface, wooden table, rough of course. Okay, anyway, if it's a rough surface also, we first have to visualize what happens if it is smooth. That I hope you all understood by now. Assume at the center of the table, there is a nail and to that nail, a thread is tied. Let's take the thread also in black. Okay. At the other side of the thread, let's say there is a small block. Okay, somewhat like this. Block or whatever it is, doesn't matter. Suppose this table is smooth. You give this block some velocity in this direction. Okay, this is the top view, let me remind you. You are looking at the table from above. Okay, suppose this block is given some speed and released. What will happen? We are pushing the box with a speed v and leaving it. What will happen?
Sir, continues to move అవుతూనే ఉంటాయి.
Okay, what kind of a path will it follow?
Circular path.
Circular path, obviously. That rope will not allow it to go out of the circle. So that block that is there will move along a circle like this. Okay, doesn't look like a circle. Is this clear to all of you? Any doubt in this? Can you all visualize the block moving like this with a speed v? Rishi, do you agree with this or not?
Yes, sir.
Okay. Fine. Suppose this is the situation, smooth surface, we give the speed v to the box and we leave it. What all forces act on the box? Anyone? What all forces act on the box?
Sir, weight, normal, and tension, sir.
Weight, normal, and tension. Correct. Weight acts in which direction according to this diagram?
Into the screen.
Into the screen. Correct. You are viewing from above. Okay. Weight acts downwards. So it's like into the screen. Let me show you the side view also. Just a moment. If you look at it from the side, the table surface looks like a straight line. Okay. When you look from the side, assume this is the table surface. This block or this lump of mass that is there, it will be like this, and the nail is here, and this is the thread. So from the side, this is what it looks like, and it will be going in a circle like this, horizontal circle on the table. And yeah, as Vanilla was saying, the forces are correct. Its weight will be acting vertically downward. So when you see from above, it will be like into your screen, and there will be a normal force acting on it. Normal force acts this way. And there will be a tension also acting on it because the string is connected, and string won't allow it to go out of the circle. So there will be a tension acting this way. So in the top view, if you see, normal force will be towards you, weight will be away from you, tension will be acting towards the center of the circle. And you all told that it will execute circular motion. That is correct only. And circular motion requires a centripetal force. What is the centripetal force in this case?
Sir, tension.
Tension itself is the centripetal force. It's obvious from the diagram that the only force acting towards the center of the circle is tension. So tension is the centripetal force. So if I ask you, how much is the tension in the string? What will your answer be? Anyone?
mv square by r, sir.
mv square by r. Tension is the centripetal force here. Mass is m. Let's assume the mass is m. Speed is v. Radius is nothing but the length of the rope. Okay, so you can equate it to mv square by L. Okay, that's the formula for centripetal force. We all know that. Okay. Now, same situation. What if the table is rough? Okay, wait. No, don't consider that rough situation yet. Smooth itself, we have given it a speed v and released. Will it continue with that same speed, or will the speed change? We have given the speed v and released it. If the surface is smooth, will it continue the same speed or will the speed change?
It will continue with the same speed, sir.
Okay, how do you justify your answer? Why will the speed not change?
Sir, because no force is acting on it.
Don't say no force is acting, forces are acting. Why will the speed not change?
Like opposite to the direction of velocity, no force is acting.
Okay. Rishi, did you want to say something?
No, sir, I was just saying there's no force opposing it, so it remain in the
Okay.
same.
Okay. See, Speed changes due to tangential force. Tangential force is the force acting along the same line as the velocity, along this line. Okay. Now, when you see from above also, you know weight is acting into the table like this. It's not along that white line. It's perpendicular to that white line actually. White line is on the table. Weight is perpendicular to the table downwards. Normal force is perpendicular to the table upwards. So normal force is also perpendicular to that white line. Tension clearly is perpendicular to that white line. Tension acts along the radial direction, not in the tangential direction. So there is no tangential force at all. So its speed won't change. It will keep on moving with the same speed v. Okay, hope the idea is clear to all of you. Now you all think and tell me what will happen if the table is rough. Second case. Same block given a speed v, released. Think carefully and answer what will happen if the table is rough. I want you all to just visualize the motion. Okay. Will it continue moving with the same speed? What will happen? Will it come off into the circle? On the circle itself, it will speed up, slow down. What is going to happen? Think and answer carefully. Okay, what is the difference between the previous case and this one?
So friction will oppose the movement of the block.
Friction will oppose sliding. Correct. So whatever forces were acting before, those forces will continue to act. Tension should act because this block, due to its velocity, has a tendency to move off like this. Okay, but the string cannot extend. String is inextensible. So tension will get developed in the string and it will turn the block. Okay, so tension will act. Weight and normal force will anyway act. That is not negotiable. This time, since the block is sliding on the table, friction will act. Can one of you tell me in which direction friction acts? What kind of friction acts and in which direction it acts? That is the question.
So kinetic friction will act
Kinetic friction will act. Why?
because the block is already sliding.
Obviously, the table is at rest. Block is sliding. Kinetic friction will act. In which direction will it act?
There's opposite like
Opposite to?
velocity of the block.
Okay. See, friction always tries to prevent sliding. To prevent sliding, it has to act opposite to the direction in which the object is sliding. The object's velocity you can see, friction has to act opposite to it. Others, why are you not answering? Like, Pawan, what was your idea when I asked what kind of friction acts and in which direction it acts?
Sir, same answer.
Okay, fine. Aishwarya, what were you thinking? Aishwarya is not unmuting. Okay, Rishi, what were your ideas?
Sir, it's supposed to be kinetic friction only, since it's already been put into motion.
Okay.
It doesn't have to overcome the static friction.
Okay. So this time there will be friction acting on the block in the exactly opposite direction to its velocity. Fine. So that's the difference between the previous case and this case. Even if you are asked this question directly, you should consider smooth surface first, visualize what will happen, then only include friction in the visualization process. Okay. Now you all tell me what happens to the speed of the block. Will it move with constant speed like it was moving in the last case?
No, sir.
Definitely not. This time it is going to slow down because of friction. Okay. And not just at this position, you consider any other position also. Let's assume it reaches here. Okay, when it reaches there, it will rotate a little bit. Let it be. Okay. If it reaches there, like it should have sufficient speed to get there. Okay, let's assume it has that sufficient speed. If the block reaches there, block or that small object, okay, then at that instant, tension will be acting this way. Tension always has to act along the length of the string only. It has no other choice. If it is still moving, of course, it will be moving with a much lesser speed. It would have slowed down by then. Then friction will still be acting on it and it will act this way. Friction always acts opposite to the direction of sliding if it is already sliding. That is what will happen. So throughout the motion of the block, friction will always act opposite to its velocity. Therefore, friction, which is kinetic in nature now, will behave as which force? Friction behaves as which force? Centripetal or tangential?
Tangential, sir.
Tangential, obviously. And it will retard the block. Speed of the block will decrease. Okay. Now you will have to find out how far the block will slide before stopping, how much its speed will be at any time. And if you know speed, you can tell centripetal acceleration, you can tell centripetal force, means you can tell tension at any time. In the previous case, when the table was smooth, the speed wouldn't have changed. Okay. And if the speed wouldn't have changed, tension also wouldn't have changed. It will always be mv square by L itself, only the direction would have changed. Okay. Because when the box reaches here, tension will be this way. When the box reaches here, tension will be this way. But if the speed is same and the radius is same, the magnitude of tension would have remained the same in that case. Okay. But in the case where the table is rough, the speed changes, therefore tension will keep changing. Finally, you all know, like at one position, the box is going to stop. The block will stop moving. That time you tell me, let's say the box stops moving when it reaches here. One of you tell me, how much will the tension be at that instant and how much will the friction be at that instant when its speed becomes 0? How much tension will act, if any? How much friction will act? Is there need for friction to act after it stops?
No, sir.
No. Okay. Sliding has stopped. So there's no need for friction. And see, some of you may feel that maybe there will be a tension acting. Maybe tension will drag the block towards the center. That is meaningless, no? Will a string, like string will exert tension as long as it has a tendency of getting stretched. Now, when will this string have a tendency of getting stretched? When the block has a tendency to go away like this, the string tends to get stretched. Okay, because it has to keep it is attached to the block. It will have to stretch like this if the block goes this way. But if the block's velocity becomes 0, it won't have a tendency to go that way. There's nothing pulling on the string then. It's just a block at rest and the other end of the string is tied to the nail. Simple. So once the speed becomes 0, tension disappears. Tension becomes 0 and there's no need for friction to act after that because weight is perpendicular to the table, normal force is perpendicular to the table. There's nothing to make the block slide on the table. So here the friction becomes 0. Till then it would have acted. Okay. Anyway, we'll come back to this case later. I mean, we'll discuss about what happens when it comes to rest and all. So during motion, friction behaves as the tangential force. What does tangential force do here? Decreases the speed, we know that. Can one of you tell me how much friction acts on this block? Suppose coefficient of friction is given to you. Mass of the block is given to you. How much is the friction acting on the block? Wait, I'll ask Pawan, you tell. How much friction acts on the block?
Sir, mu mg.
Okay, mu into n, and here n is equal to mg. Friction, tension are acting parallel to the table. Normal force and mg are acting perpendicular to the table. They will be balanced. So n is still equal to mg. So friction, which is kinetic friction, will be mu into n. That is mu mg. Okay. This is the force acting in the tangential direction. There is no other force acting tangentially. Tangentially means along this white line. Tension makes 90 degrees with it. Weight and normal force also make 90 degrees with it. So there is no other tangential force. Then this itself should be equal to mass into tangential acceleration. So one of you tell me, how much is the tangential acceleration of this block? Okay, m gets cancelled. You get it as mu g, but because it is opposite to the velocity, you should take it as minus mu g. Otherwise, you won't get correct answers. You have to take tangential acceleration negative in this case. Okay, listen all of you. This is something new we are discussing. By definition, tangential acceleration is rate of change of speed of the object, not velocity. Rate of change of velocity is the total acceleration of the object. Okay, but only rate of change of speed is the tangential acceleration of an object. So let's assume v is speed here, no bar on it. So it's only the magnitude that we are talking about. So you can write dv, small change in speed, is tangential acceleration into dt. Integrate both sides now. Can one of you tell me what integral dv becomes? dv is a small change in speed. Integral small change, what does it become?
Del V, sir.
Delta v, total change in the speed, correct? Is equal to integral tangential acceleration dt. And total change in speed is nothing but final speed minus initial speed. Is integral tangential acceleration dt. In case tangential acceleration is constant. You can write final speed is initial speed plus tangential acceleration multiplied with time. Because if acceleration is constant, you can put it outside the integral and integral dt becomes the total time t. And this looks like an equation we have seen before, v is equal to u plus at. But the equation that we had seen before is final velocity as a vector is equal to initial velocity vector plus acceleration vector into time. That is the original equation of kinematics. In this new equation that we now derived, Vf, one of you tell me what is Vf here? It is final speed. Okay. Ui is initial speed, not velocity. At is tangential acceleration and t is time. So basically, the new thing that you're now learning is that you can write equations of kinematics for speed and distance also. Generally, equations of kinematics are for velocity and displacement. S bar is equal to u bar t plus half a bar t square. Okay. Even v square minus u square is 2as. The s there is displacement in a particular direction. So those are all vector quantities. And those equations involve the total acceleration of the object. But what we are now taking is only the tangential acceleration of the object. If you do that, then you can write equations of kinematics for speed and distance. When are equations of kinematics valid? When acceleration is constant. So for these equations to be valid, tangential acceleration must be constant. If it is so, then you can write first equation. Final speed is initial speed plus tangential acceleration into time. Whatever earlier equations you had, same equations. Earlier we had displacement s is equal to ut plus half at square. Now you have distance s is equal to initial speed into time plus half tangential acceleration into t square. Then v square minus u square is 2as. Final speed square minus initial speed square is 2 times tangential acceleration multiplied with distance, not displacement. So there are equations of kinematics which can be written like this also. And these equations are particularly useful when object moves along a curved path or a circular path. If you want to find out speed after some time in a circular path or a curved path, you can try. Okay. Now let's go back to the question. We know the tangential acceleration of this block. Mu is a constant value, g is a constant value, means tangential acceleration is constant. So we can tell what exactly will happen to the block. What will happen to its speed after some time? How much distance will it cover in how much time? This time distance means this curved distance that we can find out. So there is a lot we can tell now. Okay. Let's solve one question based on all this. Did you all understand how we are applying equations of kinematics to speed, tangential acceleration and distance? Okay. It's like the derivation is same as the derivation of original equations of kinematics. Only thing is you have tangential acceleration and speed. In the original equations of kinematics, you have total acceleration is equal to rate of change of velocity with respect to time. Okay. So in place of total acceleration, you take tangential acceleration. Then in place of velocity, you can take speed. And in place of displacement, you will get distance. Okay. Fine. Just a moment. I'll copy the diagram. Okay. Let us take some numerical values this time. Assume the mass of the block. The block's dimensions are small. Ignore it. Okay. Assume mass of the block is 2 kg. Length of the string is, let's say, 5 meters. 5 meters is actually very long, but let's assume it is 5 meters. Coefficient of friction between the block and the table Coefficient of static, kinetic, whatever you want, you take it as 0.5. Okay. And what are we doing? We are giving the block some speed. Or, okay, you find out that speed. That is the question. How much speed should the block be given such that it completes one circle? It just completes one circle. Okay, try this, all of you. Because you know, if you give only a small amount of speed, it will move maybe till here and stop. You increase the speed, it will move some more distance and stop. You give sufficient speed, only then it can complete one circle and stop. That speed is what you need to find out. Try. Any answer, anyone?
Sir, I got answer in terms of pi.
Let it be. Keep pi as it is. Don't substitute anything. How much?
10 root 5 pi, sir.
Okay, we'll see. Others, any answers? We want this object to complete one circle. So that means you know how much distance it has to move. and we want it to just complete the circle, means after completing the circle, it comes to rest. So you know its final velocity also. I think you all should do it. I'll give you 1 more minute. Try this, all of you. And just unmute and tell if you have any answer. You'll all be able to do it. It's not difficult. Pawan, tell if you have any answer. Don't like keep it with yourself.
Sir, same answer.
Okay. Rishi, any answer?
Sir, I'm still solving it, sir.
How are you trying to solve?
So the distance that should cover it is pi r square.
Pi r square is not a distance. What is the distance of one circle? Pi r square is the area of the circle.
Oh, 2 pi r, sir. My bad. Yeah, sir.
Okay.
I just have to solve.
Fine. The distance it has to cover is 2 pi r. The initial speed is what you need to calculate. We know the final speed becomes 0. And we also know that the acceleration of this block, okay, like in this case, is minus mu g. Tangential acceleration. Minus mu is 0.5, g is 10. So it's like the acceleration is minus 5 meters per second square. That's all. It will be constant. As long as it slides on the table, it will be constant. You can use equations of kinematics for speed, distance, and time. So which is the appropriate equation? You are asked to find the speed. You'll have to use v square minus u square is 2as. That's all. 2 into tangential acceleration is minus 5. The distance it covers is 2 pi into 5, that is 10 pi. Okay, when it completes the circle, the displacement as such is 0. So these are not the regular equations of kinematics that we used to use till now. These are equations of kinematics involving speed and tangential acceleration and distance. Distance is one full circle distance, 2 pi r. So 2a s, s is 10 pi. That's all. Minuses will get cancelled. You will get u square is equal to 100 pi. 2 into 5 is 10, 10, 10 is 100 pi. So the speed, initial speed becomes 10 root pi. Is this the answer you told or some other answer? Both of you.
Sir, I did
Sir,
some
same answer.
calculation mistakes.
Okay, okay. Fine. So that if you project it with that speed and leave, it will be able to just complete one circle. Okay. Suppose it is given this much speed initially. Okay. You know there is friction on the table. The carom coin or object is going to slow down. I want you to find out what it's, okay. You find out whatever is necessary. When the coin reaches here, what is the tension in the string is the question. So when it completes half the circle, or you can say when it reaches the diametrically opposite point, how much is the tension in the string? Okay, just for your visualization, I'm showing the diagram. You know the question. Speed is, initial speed is 10 root pi meters per second. Find out the tension when it reaches the opposite side of the diameter. Any answer?
Sir, 10 pi into m, sir.
10 pi into
M.
mass is given. So 2. So you're saying 20 pi.
Yes, sir.
We'll see. Any other answer? Rishi, tell me, what idea will you use to derive tension at that instant?
Sir, I'm not sure.
What is tension doing there in this situation? Pawan,
సార్ అంటే ఫస్ట్ నేను అక్కడున్న వెలాసిటీ అనుకున్నాను సార్.
why? Why will you find out the velocity at that point?
సరే అంటే పాయింట్ వెలాసిటీ చేంజ్ అవుతుంది కదా.
Point velocity changes. Okay, you want to find out velocity, you find out. Then?
దాని మీద టీ ఈక్వల్స్ టు mv స్క్వేర్ బై ఆర్ పెడతాను.
So when I ask why you want to find out velocity, you should tell that. Tension provides centripetal force. Centripetal force depends on the velocity. That's why we have to calculate velocity and chepte ayipothadi kada. Okay, correct. So as the coin slides along the table, the forces acting on it are weight normal force, which are perpendicular to the table. Friction acts opposite to velocity. Tension acts towards the center. So at any instant, not just this instant, any instant, tension is the centripetal force. So you can equate tension to mv square by r. So you'll have to find out the speed at that moment. And Pawan, how to find out the speed after it completes half the circle?
సార్ v స్క్వేర్ మైనస్ స్క్వేర్ 2as.
You want to use v square minus u square is 2as, correct. So v square minus u was 10 root pi. You square it, it becomes 100 pi. V square minus u square is equal to 2 into, how much is the acceleration? Tangential acceleration?
సార్ -5.
Minus 5. And what will you take in place of s? S is distance or displacement now?
సార్ పై ఆర్.
It's the distance. For half the circle, distance covered is half the circumference pi r. Pi into radius is the length of the string, which is 5. That's all. So 2 into 5, 10 5 is 50. So this becomes minus 50 pi. Now send the 100 pi this side. You get v square is equal to 100 pi minus 50 pi. That is 50 pi. So v becomes under root 50 pi. 50 is 25 into 2. You can take the 5. You can take it as 5 root 2 pi. Or you can write under root 50 pi also. Nothing wrong in that. What answer you finally choose depends on the options, because you all are going to be taking objective exams. Vanilla, what was the answer you told? Okay, the actual question is tension, no? Fine.
20 pi, sir.
It's still not over. Okay, we got v square as 50 pi. And we'll substitute this here. Therefore, tension becomes, mass is 2 kg. V square is 50 pi divided by the radius in which it is moving is 5 meters. 5 gets cancelled. The answer is 20 pi newtons. Correct. So basically, you can tell anything about this object. Like when it reaches the diametrically opposite end, we could find out. You can tell how much time it takes to complete the circle. And at half of the time where it will be, you can tell what the tension will be. You can tell what the speed will be. You can tell all those things. Okay. So you have learned a new idea today. Using tangential acceleration, you can write equations of kinematics for speed distance directly. Okay. Fine. So see, this much of practice is enough on laws of motion. Actually, in the next few chapters also, work energy power is the next chapter we are going to start. And after that, system of particles, after that, gravitation. In all those chapters, these ideas will be applied. So you will become stronger in laws of motion as we progress through those chapters also. We'll again be considering forces, acceleration, displacement, all those things we'll be doing in those chapters. Okay. So practice some questions, and tomorrow by afternoon, I'll send you one worksheet. You'll have some questions based on these situations, friction on a table and all. And you will have one part in the worksheet based on something called dot product of vectors. Okay. Because in the next chapter, work energy power, to calculate work, you need to know how to multiply vectors. Till now, we have done addition, subtraction of vectors, parallelogram law, triangle law, component form, you know how to add, subtract. To calculate work, you'll need to know how to multiply vectors. And in tomorrow's worksheet, you'll have one part based on dot product of vectors. It's easy. Okay. All the hints, all the steps will be given. I want you all to solve that worksheet and send by Sunday evening or Monday before class. So 2 full days you will have. Some 1.5 hour it may take solving that worksheet. You solve and send. Okay. Because we'll just briefly, like if you do the worksheet, you can understand dot product. It's not very difficult. In case I find that some of you are not understanding at all, then I will teach dot product, not an issue. Okay, thank you all. We'll continue on Monday.